Alright guys, it's been a minute, but I'm back. So yeah, more coding. So I was looking at the Busy Beavers, hold up, wait one second. Alright, I'm back. So yeah, today I plan on trying to code this algorithm. Okay, where is it? It's right here. It's in this video, at least. I guess they explain how to do this. So yeah, I'm just trying to code this algorithm. I'm thinking I could probably do it. Maybe. I don't know, but yeah, bro. I was thinking of coding this for practice, also to learn a little bit more. So yeah, I'm gonna update the screen. There we go. It should say in the bottom now. Yeah, trying to code CTM. Let me turn down the volume a little. All right. So yeah, a little update on the code. Let me update the stuff. All right. Let me update this stuff. I'm just gonna say added. All right, great. So yeah, push to the repo. Cool. Okay, so let's go into Turing. Let's run 8 out. Look how quick that is. It could be quicker, to be honest. It could be quicker, but I'm not gonna bother. The main thing is I updated the code. Let me see. Did I add this? I don't think I added it. Yeah, I'm gonna have to add that. I'm gonna have to add that. So I got it right here. It's been a minute, so this code might not even work with, okay, I don't know. Let's see. I'm going to see. Bro, this song is crazy. Can't be having this. Cannot be having this. Okay, let's see. Come on now. Come on now. Compatible with the observation. Can be approximated from above. Okay, here is the theorem. So they have a thing here, M. And they're saying that this plus a constant is the complexity of a string. Interesting. So I have to sum up all the Turing machines up to a certain length, and then I don't know, I can plug it into this formula and it'll estimate the conglomerate complexity. Interesting.
Don't know what to do. Burning in my mind is an image of you. Sitting here burning, baby, yearning for you. My heart it starts racing when I think of you. I'm losing control. I don't know what to do. Burning in my mind is an image of you.
So here's the algorithm. Here's the algorithm. So this is the number of times that a machine with n states and 2 symbols produces a string over the total. Okay. So this is pretty simple, I guess. This is an estimation. Okay, so oh my god. One of their final calculation took 1,970 days. and it was just a sample. What? Wait, full space f minus 500? F minus... What does F minus mean? What is R? So R is reduced enumeration. This is that's a lot of stuff. That's a lot of stuff right there. Oh my goodness. And what's the formula again? What is the formula again? So you have M of a string, which you put in a program, and the program has a certain length. Okay. Goddamn, bro. Goddamn, bro. So the problem with our code... So yeah, I definitely need this code. I definitely need this. Yeah. Alright, I'm gonna read this. And, I'm gonna put this here. So let me show you guys what I did. You know, what did I do exactly, actually? Is this even correct? I do not know. I do not know. I was looking for something here. I was trying to enumerate all the possible strings that I could have for these. Right? Oh, this is correct. This is correct. So this is per thing. So it's 24 to the 10th power is the total. God damn. 24 to the 10th power. I'm saying it's that much because this is a transition, right? And a Turing machine, in my implementation, it has n states. It's assumed to have two symbols, and the number of transitions, all right, equals 2 times the number of states. Okay, because it's 2 symbols per state, whatever, and you know the number of transition thingies, or like the number of combinations per transition, right? One transition has n plus 1 times 4 like possibilities. Isn't that how that works? Yeah. So you would have n plus 1 times 4 to the power of 2n possibilities in grand total. Okay. And so let's plug in 5. Let's not plug in 5, right? Well, can we? We get 5. Yeah. Because look, if we have 5, for example, we have 5 states, which is what we kind of, this is an example of one of them right here. This is the Busy Beaver 5 state. Anyways, but yeah. So we would have 4 times 6 to the 10th, which is 24 to the 10th. And that's a big number. And that is basically the number of Turing machines that we are considering for our Turing machine implementation. Yeah, so that's what that is about. So okay, so yeah, now that we're situated, now that we got that out of the way, I wrote an algorithm to enumerate all the different possibilities. So remember there's 24 possibilities, right, for each whatever, it's this one. Each transition has 24 possibilities. I made an algorithm to enumerate each transition. Here they are. Right, 1 of the 24. These are all of them for n equals 5. And I made a second algorithm that would enumerate all the transitions, not just like one individually, just all of them. And I basically it's the transitions is just, look at this. Transitions, there's 10 transitions. There's 2n transitions, right? 2n transitions. And but they're like in a string, so that's why you have to the 10th, because for the first transition you have 24 possibilities, for the second transition you have 24 possibilities, and you get 10 transitions, so it's just multiplying 24 10 times. And this is what it looks like if you only had 2 transitions. And that's right. My algorithm said 576. Right? That's 24 times 24, right? Yeah. So that's 24 to the second, for example. But that's not all the transitions. That's only 2 of them. We need to generate 10. And that's really easy because I wrote it down somewhere. I forgot where. I think it's this one. I put something somewhere where it only generates like 2 of them. I really don't know where. Oh, it's right here. I put 3 times 2. Okay. If I did 3 times 3, it should generate, you see, it's going through all of them. Let's take out the this last one. We don't need the last one. Right. So if we had 3 transitions, it would be this much. Let's make sure. 24 to the 3. Yeah, that's correct. So this algorithm basically works, right? If I put this to be 10 instead of 3 and 2, right? If I put a 10 right here, let me just put 10. Why the hell not? This will take forever. This will take so long because 24 to the 10th is such a huge number that it'll take so long. This is a big number. I don't even think this fits in I don't even think this fits in integer. Like, I don't even know. Let's see. Uint max value. Let's see what this is. So uint is maximum this amount. So we have 1, 2, 3, 4 threes. 1, 2, 3. Yeah, it's still too large. Yeah. If we did u long, it would be bigger, hopefully. Unsigned long. Unsigned 64 max value. And C. Okay, we can definitely do it in unsigned 64-bit. So we could do that. This... Did I stop it or something? Yeah, I think I stopped it. Bro, goddamn Marvel Rivals. So let me keep track of that. So the count I put right here. So how to get unsigned 64-bit in C. Isn't that like unsigned long? Nah, I'll just do this. It's probably more... That's probably more consistent this way. Alright. Okay. Where the heck? Where's the goddamn... There we go. So the count goes pretty big. I mean, it's pretty freaking slow. It's pretty slow. But you know, let's make this quicker. So it's not gonna print every single time. It's gonna print every 1,000 times. Let's see about that. How slow is that? Oh crap. What? Wait. Yeah. Okay, obviously still gotta increment it. There we go, much quicker. Look at that. Much quicker. Let's add 2 zeros to it. Wow, look at that. Let's add 2 more zeros to it. Oh, it's a little slow. We're seeing the limits here. The goddamn limits. It's getting pretty far. Pretty far. So the point is here, this code works to generate these things pretty quickly. Oh, there we go. It went negative. I think it overflowed. Yeah, it definitely overflowed. So we don't really need the count. You can just put a 0 in there. See how quick this goes. This is every million or whatever this is. I don't know. But yeah, I don't know. Permuting through these is very quick. So yeah, but actually simulating the Turing machine has to be, I want it to be quick, but it's not gonna be that quick, to be honest. It ain't gonna be that quick. There's gonna be a lot of Turing machines that never halt, and yeah, that's just not it, bro. That's just not it. Okay, so let's see. Let's see here. So what are we gonna do with this code? Let's do some reading. Let's do some reading. So I think this is good. This number has to be the states, pretty sure. So it has to be this, a t underscore 2 times t states, and this has to be -1, because in the code this is +1 for the states, because it includes the halting state. So yeah. Okay, so we have t states. Let's define t states here to be 6. Let's see how long that, yeah, it's about the same. I think it's the same. So that's good. Alright. Do you guys like the background by the way? I added a little background. I think it's cool. I think it adds a little flavor to the video. So yeah, so this is this. This is whatever. I still got these. I got this thing here, got this thing. This, let's move it up a little just to clean that up. Print Turing. Yeah. Maybe I should add like a header for this. Maybe I should clean up the code a little just to make this easier to work with. Like, I don't know. I'll probably keep it here. Okay, so we got this. I'm just trying to make sure there's no like hard-coded stuff in here and that I could change the number of states easily. So I think I'm gonna keep this here. Yeah. So here we got that. So this has to be t states minus 1 as well. So t states minus 1. This should probably be 6 with you know, all that good. So there's 3 in that thing. Let's see. The count, we probably need the count to be this number, so we probably still need this thing here, which is alright. So that's cool. This kind of works. Yeah, so we got a count, we got the maxes, and this Turing string. So this is where the string ends up. So Turing string, the maxes. Yeah. I should probably make a way to zero this or something. Yeah. Okay, I have another question for myself. Nah, I don't know what the question is. Alright, I think this is ready. Ready to paste. Ready to put into here. So I'm gonna erase all the triples code here that I was doing, and then I'm gonna put this new code that I just added. Alright. Okay. So let's paste that. Okay. So we got some stuff here. Right. This is all good. I also put this. I might keep that there. Why not? So, oh, I could have pasted it further up. Bro, I need Vim. need Vim because I'm using Nano right now, and I'm limited to like copying and pasting, and it's in a weird way, you know. All right, the strings. Okay, so I can generate. Oops. I can generate the triples, all of the Turing strings. So what I was generating specifically was this, the function string, except for, so I'm generating this, something like this. That's what I showed, but it doesn't generate this. This I'm gonna have to do that, but I'll mess with that. I'll figure that out. So here's what I'm gonna do. So here we have a Turing string. So there we have a Turing string. I have a question for myself. Probably need this. Can't forget that. Okay. So okay, so I think I'm ready to start generating these strings. The only problem is I need a way to put this in the beginning of the string. Yeah, that's gonna be really easy, guys. Don't even worry about it. Don't even worry about it, bro. Don't even worry about it. Okay. So here I have actual Turing string. Right. This is gonna be that, and right here I'm gonna put this +1. And here I'm gonna say this is a pointer to right here. Alright, it's gonna be a pointer to right there. And it's gonna be this. Whoops. It's gonna be this long. Okay. And the reason I'm doing that is I have to initialize this. I'm giving it +1, so it has space for that first, for this thing. So yeah, that's why I did that. And the code that generates the strings uses this array, and it does not expect that first thing, so I move forward 1 space because that's where the other thing is going to be. Yeah, so here I'm gonna try to do this. So let's run print Turing chart. Right, so we're gonna print Turing chart. So we're not going to initialize this. We're going to do the print Turing chart. Honestly, I expect this to not work. Yeah. Okay, first I gotta run. I gotta do goddamn tmux, bro. I gotta do tmux. Oops. Is that? No. Okay, gotta do tmux. Zoom out a little. Go here. Okay, and then I go here. Okay, I think it's about time I make a build script. Nah, screw that. There's only one file. There's no such thing as a build script. So for this, what is it? Just GCC. And then we're gonna run it. So GCC. Yeah. So this is an invalid initializer. Let's look at that. I kind of figured this would give us problems. I don't want to do this, but like, yeah. If we're gonna make it an array type, you know, it's probably gonna have to be like that. Oh, look at that. It's doing it. It's literally doing it. So it's a little quicker, I think. Is it quicker? Huh, let's see. I don't know. It's probably quicker, but who knows? Yeah, I don't really care. Let's add a clear on there. Yeah. Alright, so that is working. It prints out 0 for everything. Cause yeah. So what are we doing now? We're trying to make a Turing machine that runs based off of this string. So let's make a thing for that. Run until halt or busy beaver val. All right. So that's a long. That's yeah, that's a long thing. Run until halt or busy beaver. Let's just say that. Yeah. Okay, so this has to be pretty straightforward. We just do a step. Alright, so like so it returns true if it halts. Alright, that's what that does. So let's also maintain a counter, which I will just put uint 64 because why not? That's got to be good enough. Let's equal it to 1. So so while this, so run it until it halts, which is this condition, or the counter exceeds a busy beaver value. So let's let's put these numbers somewhere. There's probably like a steps. I don't know, man. We gotta put this somewhere. We gotta put this somewhere. This can't be that crazy. So we're just gonna go online. Yoink those busy beaver values. It's here too. It's here. So known results. Let's get that beautiful dark mode. Here is the table. So what we're looking for are these numbers. Wow, this is pretty small. Pretty small. So for 2 states, it'll run for 6 steps, or like if it runs for more than 6 steps, we know that a 2-state Turing machine will just run forever, and equally for these. For 3 straight, it's gonna be 21 steps. If it runs, we know that if we have a Turing machine that runs with 2 symbols using a certain implementation, the one I have in my code, if it runs for more than this number, it'll never stop, never halt. Same for this one, same for this one. So yeah, let's copy paste these numbers. Okay, so let's do that. So if it has 1 state, I don't know, I'll just say it's like 1 or something, and 0 state is not a thing. It is not a thing. So this is t states -1. This is 0, 1, 2, 3, 4, 5. Okay. I'll put like 2 here. I don't know. So yeah, if it's got 0 states, it's never. There's no code. There's nothing. If it has 1 state, I guess this one. 2 states, 3 states, 4 states, 5 states. Okay. Okay. So we count every step. If it increments greater than thingamajigger, then or if it's smaller. Oh, it has to be and it is smaller. Right. Let's just make this easier to think about. So it doesn't halt, and the steps has not exceeded the known busy beaver thing. So that's what we're gonna do. Run until halt or busy beaver. So that's that. So yeah, that's it. This is the loop. That's it, actually. That's the code. So that's cool. So we're gonna run until halt or busy beaver. When it comes to the tape, what I'm gonna do, because we have a tape I, right? I want the tape I don't know. What did they do for that? How did they, because on here, it generates an output, right? Like you put in a program, it generates an output. But how do you like determine the output? Like, is it using this? Like, the tape starts at 0 and it goes forward. I made the tape size to be 13,000 because I know right here it tells you the space that it uses also, which is cool. For 5 states, we know it's 12,000 whatever. It's gonna be this. The maximum for your halting 5-state Turing machine 2 symbols is gonna be this number. So I just put 13,000 for easy number. What if I put a power of 2? That could be cool. What if it's 13, 12, 11, 20,000? It's probably, yeah, so 2 to the 11th. Oh wait, no, JK. JK, guys. Just kidding. Just kidding. Let's look on the calculator, the trusty old calculator. So 2 to the 14th will hold our stuff. Can this, let's make this cleaner. 2 to the 14th. I don't know if that's 2 to the 14th. Let's use trusty online compiler. Online compiler, what do you say? What do you say? 32,000? Nope. 2 to the 14th is 16,384. What if I do this? 0, of course. Oh, it's probably 1. That's how you do it, yeah. That's 2 to the 14th, so the 1. My bad. Okay, so let's put these all in like that. That's the tape size. This, by the way, I'm gonna also put that in parentheses. Yeah, all the parentheses stuff, all the defines I want in parentheses. Okay. Maybe our Turing machine will get quicker by using a power of 2 for the tape size. I really doubt it, but whatever. Okay, so wait, do we have a cursor? Okay. So what are we doing here? What are we doing? Let's we gotta do something. We gotta decide right now how to handle like the tape. What does it mean for an output of a Turing machine? Let's what is considered the output of a Turing machine? A sequence of symbols remaining on the tape. Where's the output? What does the output mean? So it's right here, which is a book. No, I don't want a book. I want an actual... Oh, here we go. Let's say there's an output. So it says whatever is written on the tape at the time of halting is the output. Okay. So reading and writing symbols and changing and possibly writing a new value. So the output symbol. Oh, here we go. Here's a Turing machine. They got some Turing machine stuff. So they're saying here. So I guess we really do just look at the tape. Okay, so what I'm guessing... So it's the tape I, right? Tape I. So tape I starts at 0. I would consider the output to be whatever's on the tape from 0 to wherever it halts. So I guess if it goes backwards, because what happens if it goes backwards, you know? Like we start at 0, alright, and then you halt at a specific other location. Do we always read it like to the right side of things? You know? Does it matter what we pick? Like how we get the output? What if we get the output like every other cell in the tape? Like every other cell. That'll be kind of weird, but nah. Alright, I think I'm gonna get the output just as simple as I said. So it'll be from 0 to wherever it halted. So that will be what I consider the output. So this has gotta be pretty easy, right? All you gotta do is, it's a pointer just from T-tape, and then, I mean, it can't be that easy, right? Because what I did here, I did something. God damn it. Yeah, motherfucking damn it. Let's see. So I got some debug statements here, which I don't need. This is not debug, this is just an error. This I put a thing here, fixed, which is I put modulus on it. So yeah, I put modulus. The thing is, I don't even know if this is right, but this still works though. This works, because it can run, I don't know, Busy Beaver 5, which is like cool. That's cool, but problemo, how do we know? I don't know, bro. I gotta just code this. No, I gotta figure it out, bro. Gotta literally figure it out, because it's not gonna work if I don't figure it out. So we got the tape, and I'm assuming the output is from 0 to wherever it halted. If this goes negative, my solution was to wrap it around and go to the end of the tape. Yeah, that's what I did. Because let's say the tape was 100 in size. If I did -1 for the tape index, so that means it went backwards 1. I don't like this. I just don't. Nah, bro. No, I don't like this. What I'm gonna do, maybe I could do something different. I could do something different. I don't know. Because Turing Machine's kind of crazy, bro. Turing Machine's crazy. Turing Machines, bro. Turing Machines, bro. Because, like, how do I consider the string, you know? Oh my god. Okay, I have a better idea. What if, instead of it's just where it halted, it's whatever it printed on the tape? That could be the output. So it's as simple as keeping track of the leftmost tape position that it visited and the rightmost tape position that it wrote to, and everything in between would be considered the output. How about that? How about that? How about that? That's pretty cool, I guess. I truly don't know what these other people did. Maybe we could keep playing. Minimum number of instructions. They got a computability, lossless compression. What? So they have a list of probabilities here, which is interesting. Constant in the invariance. I don't even know what that means. I'm not about to find out. Alright, let's go back. Let's see where they talk about the output. It's literally just this. Just this. So they have U, which I'm assuming is universal Turing machine, or just some Turing complete function. That's what I want to know. How do you consider the output? Bro. Green, red. writing and changing. Changes state. It says whatever is written on the tape is the output. Okay. I mean, I guess that makes sense. It's just whatever is written on the tape. So that doesn't care about the implementation details. It's just whatever's on the tape. Okay. Okay, so let's find a way to implement that using our code. This is kind of loud. So we got the tape, right, which we said starts at 0. I think we can do this. Okay, here's what I'm gonna do. It's not gonna start at 0. Let's not do start at 0. Let's do that it starts in the middle. Okay, so we're gonna have this divided by 2. Okay, this divided by 2. And this is integer division, so it's all good in the hood. So it's gonna start in the middle, and I can start it in the middle, and then yeah, if I do that, I don't have to. Excuse me. I don't have to worry about it wrapping. If it goes negative, wrapping around, you know, I could just consider it to be whatever it is here. So I'll start it in the middle, and then, you know, everything to the left of the middle would be considered negative, but I don't even care about any of that. I'm just gonna keep track of the leftmost and the rightmost, and I don't want to complicate the indexing of the tape. Just want to keep it like from 0 to the end of it. So I don't think I have to do this thing here anymore. This is kind of dumb. So let's go all the way down and go back to doing the Busy Beaver. See if it works. And it still works, so that's cool. So we changed the starting position. That didn't break anything. I don't think I need this. I don't think I need this anymore. We can just check the bounds, you know. We can just check the bounds. So I'll just do this. Alright. Make this easier. Okay, so you got that, and then this. We don't need all this weirdness. We can comment this out. We don't even use it. Oh my god, we do use it, actually. My bad. It's just that this is different. Yeah. Okay, right here. We don't need that. And I put high at the end there. So if t state equals 0, halt. Okay. So this is good. So if this is smaller than 0 or greater than or equal to the size, then This is an error and we should halt. Okay, so let's write that, and oh, it went to -1. Interesting. So it does go too far, eventually. It does eventually go too far. So the tape size, let's just do 15. What is 15, by the way? 2 to the 15? 2 to the 15 is 32,000 something. So 32 kilobytes. That's, you know, whatever. Whatever. So I just gave it more memory. Give it more memory. It's as simple as that. So let's, I want to not have this print with dish. Taking that out. And I want to put dish. I want this to return how many steps, like how many steps it took. So just for purposes, you know. So I'm gonna do this because this is code I have already. So let's output that, and okay. Oh, here I'm supposed to put LD. GCC, you're so smart. So smart, GCC, thank you. Look at that, very nice. Okay, so this is cool. So run until halt or busy beaver. So, okay, so this is cool. This is cool. So what we're gonna do now is write a way to get the output. I'm guessing the output on the tape. So like keeping track of the tape, the leftmost written tape thing and the rightmost written tape thing. So is it what is written? Yeah, whatever is written on the tape is the output. So the leftmost thing would always be a 1. That's nah. It can be a 0 because it's whatever's written. Okay, so let's put T leftmost I and T rightmost I. These will be 0 for now. Yeah, so no, it's not 0. It's not 0. It's this. So that's that. So yeah, so right here we're just gonna keep track of that. So T leftmost I equals min of T leftmost I, or the current tape position, and the same for this, except it's gonna be max So the rightmost I is whichever is greater of these two. And I don't think this will compile because we do not have, it says it's not a constant, so it doesn't work. Yeah, I mean, come on now, come on now. Is there like a fast, do I have to just code these? Is it already in C? What? I'm not looking for certain documentation. So is there min? Is there like a math thing? Expressions, functions. Is there a library? Is there a standard library? Does the standard library have that? Standard library, min and max. Is it in there? It's broken beyond. Yeah, that's kind of funny. Yeah, that's true. That's very true. Okay, let's just do our own easy peasy max function. So we have A and B. Right, the max of A and B is going to be if A is greater than B, return A, else return B. Simple as that. That's max. So yeah, if thingy else thingy. Okay. So if A is smaller than B, and I don't think we need the parentheses there. This is code. We can. Wait, what? Is this how this works, by the way? Wait. No. We gotta use ternary. We gotta use ternary. Nah. Okay. Okay, goddammit. Does C have ternary? Ternary operator. Yeah, it does. Good. So A greater than B, A or B. Okay. Minimum is A smaller than B, return A, otherwise return B. Yeah, cool. So that's our easy peasy right there. Oh my god, I just... What's the deal here? What is the deal here? We cannot initialize this to be a constant. Oh, it has to be. Oh. My bad. My bad. My bad, fool. My bad. Alright. So there's more errors. Rightmost is undeclared. Did I type it wrong? T rightmost I? I don't know, it's definitely declared here. Let's look at this. So T. What did I put R. Wait, what? Oh my goodness, put R. That's what that means, right? Yeah, there we go. There we go. Okay. And let's also make a reset. Okay. A reset. Because we are gonna need that. We are totally gonna need that. So here's the reset. We're just gonna set all these right here to whatever they equal to. So I'm gonna do this, and we're just gonna take these down. This is why I need Vim. Alright, I know I need Vim. I don't care. So yeah, if we're gonna reset it, the tape needs to be reset in a different way using memset, probably. The transition table also probably needs to be reset. I don't know. Yeah, we probably gotta reset that somehow. So let's reset the tape and yeah, bro. Let's just yeah, I know that's not right, but just so I can keep track. So all these things, I can reset that stuff. So it's gonna reset all that. This is becoming a little complicated because what do I do with this transition function string? Like, this is so weird. Whatever, I'm gonna keep going. Okay, so I'll put this copy right there. Let's let this be, let it be known. All right, so let's push this forward. So the state goes to 1, I guess. Let's set it to 1 for goodies, for goodie measurements. These 3, yeah. We gotta reset the tape and you know, memset, right? Isn't that how we do it? We gotta set it equal to 0. Memset to 0. So I forgot how to use memset. I totally forgot how to do this. Right. So this is what you put in the thing. It's gonna be 0. It's gonna be how many bytes. So we're gonna put the tape 0 and how many bytes. The type. What is this, by the way? Let me get to. Let's put a tape. Okay. And what is this size of tape? Come on now. 492. Why is that? Is that because it's... Oh, it's 4 bytes each. Okay. Interesting. Is that what that is? You just put size of tape? I think that's how that works. Because if I put size of int, that's not a thing. Is there like a... how do you get the size of an int? Oh, there we go. Yeah, because if you do size of int, it's 4 bytes. Tape size is this many bytes because it's 123 times 4, which is that. So yeah, I'm pretty sure I can just do this. Size of tape. And let's see if it'll even compile. Whoops. Let's put that there. There we go. Alright. It compiles. So we clear the tape. We can do that. Now we gotta clear this thing, which is kinda odd. How do you... what's the size of this? So isn't it the size of this times 2 times this? This is also... this is a pointer. Okay, this is a pointer. It's a pointer to this. Interesting. So what is this again? Let's take a looky look. Let's take a looky look. It's 3 integers. So let's make a struct real quick. Right, let's make a struct int A and B, C. Let's do that. I think we can do that. And let's put that in there. And it's 12. Good. Good. And let's put pointer. Is that correct? Pointer is 8. Yeah. So I think what I would do is I'll set this to 0 because it's 0 there. I do size of this pointer times 2 times t states, because that's what that's how many I got there. But just to make sure, let's do this struct thing, and it's a pointer and then double thing. So there we go. So we got 2, 2. So let's put, what is the size of high? So it already calculates it for us. We don't need to go crazy. Okay, that's cool. So that's very nice, very nice. So I think this works as well. So yeah, I'm gonna take this out. We don't need that. Let's see if it compiles. It still compiles. Cool. So that is the reset. Let's make a function for, I don't know, the output. I want it to be the output. So Turing output, let's call it. All right. We are going to, nah, bro. I don't know. What if I call this size? Or this is the size, and then this is just the actual like output. So this is gonna return tape plus t leftmost I. Alright. Okay. And the size is going to be t rightmost I minus t leftmost I. Right? Okay. So that's the output, and then the size. Okay. So there we go. What if I do this instead? What if I do this instead? What if I do this instead? So put the end, and then it's gonna be t-tape right there. T-tape plus the rightmost. That's gonna be the output end. You need the size in case we want to use it, but we could use these two. Okay, so that's cool. That's cool. I forgot why we were doing that. Okay. So here I'm gonna do print f I wanted to do that. Okay. So okay, I'm gonna make so this is actual Turing string. Okay, so this part of the code, I've got code for generating the triplets, the transition triplets, and above that is like Turing machine specific stuff. Okay, and here's the transition function something. This is a busy beaver. Okay. Bro. Okay. Let's just, I don't know, bro. I'm just trying to make a freaking, I'm just trying to implement this, right? So CTM, you know, where's that formula? It's like right here. So all I gotta do is iterate over all the motherfucking programs that generate a string, sum up using this sum, and then motherfreaking, I don't know, do something with that. Just trying to do something with that. Okay. Oh, I know what to do. Alright. Alright. Here's what I'm gonna do. I will make a function. I don't know, bro. I'm just gonna do this directly, because I was kind of like thinking that maybe I should do something in between, like maybe enumerate all the Turing machines. Alright, let's... Okay. I don't know, bro. I don't even know. This is like a... This is like... There's some voodoo right here. There's some juju. There's some juju right here. Alright, so run until halt or busy beaver, which works. One thing I gotta do though is all the way in the top right here. This needs to be able to change. I think I have to be able to change that so I can iterate all the Turing machines of different states using the same code. So, you know, goddamn, bro. Goddamn, bro. Because it ends up here in this macro. I could change all these to not be macros and just be like an integer, not even a constant, because I need them to change. It even ends up here. So let's do that. That's a good thing to do. So let's call this T number of states. Simple as that. Number of states. And we're gonna comment that the tape size, I'll keep that the same for now. These keep the same. This, I need that. This, I'll just keep it, why not? So I'm gonna need to do stuff with this. Alright, here's where I come in with the magic. So what I'm gonna do is use Linux and replace all instances of this with this. Alright, a little Linux magic. I'm gonna ask the internet how to replace string file with sed. consider the following. S for substitute, global. Yeah, so let's do this. So this goes here, this goes here, and this is main.c, and that's it. So let's exit and ba-boom, and let's go back. Look at that, magic. It's been replaced. It's all been replaced. Excuse me. So this right here. Oh, that's not good. I think this has to be a constant. That has to be a constant. Here's what I'm gonna do instead. I will make a definition for the number of states, but it's gonna be called something else. Max states. So these are the max number of states we will consider in our program for now. And yeah, max states plus 1. Max state, let's do 5. Alright. Let's just do that and try to compile it. And it's probably not working, obviously. Yeah, so we need some stuff. There's some weird initialization errors. Like, there's a lot of errors. Like, a whole lot of errors. What's going on with that? What is going on with that? What is going on with that? Hello? Is this... Why is there so many errors? Why is it complaining about the parentheses? This is not an array initializer. Excuse me? This is not an array initializer. Whatever, bro. What flipping ever. Fine. Take out the... And I guess put that as well. Okay, this is kind of weird now. It's just kind of weird. I still... I'm gonna put this all back. So what seems to be the problem here? So tape size, we got transitions, we got some states, we got T right. Let's look, open and close it. So yeah, I don't know. All right, let's take a look at what are these errors talking about? What are these errors right now? Oh, this is we gotta do max number of states here as well. Here, oh, this is where the errors are. Mr. Errors, get out of here, bro. The errors continue. That's alright. Oh, it's because right here. Yes. Errors on errors. It's still going. Alright. I will find and destroy. I will search and destroy all errors. All these errors. So the transition function. Oh. Hold up. Wait, So max states plus 1. Transition table. Max states plus 1. Hold the phone, bro. What is this? So we get the function table. You know, it's gonna be that, and then this here is this, which is this. Is this correct? I think it's, yeah, it's gonna be that. Okay. Let's read this. Is there stuff going on? Number of states, here's another one. This could be a motherfucking integer, you know? So yeah. This is gonna be the Turing. What was it again? I forgot what I called it. Ooh. Okay. Thought I messed it up. Turing triplets string size. I'll just call it T. Turing triplet string size. Yeah, and it's gonna equal this. Pretty straightforward. Pretty straightforward. And I will be using this. So this is gonna be here. Alright. We got triple stuff. This is like triple code. Okay. This, oh my god, this is a goddamn, this is an array. Oh my god, dude. I should probably make this like max. God damn it. Okay. Max Turing triplet size. Okay. Okay. So the Turing triplet size, I think yeah, string size. Max Turing triplet string size. Let's let that be. Alright. Let's let that be. And let's take out the plus 1. We don't need it. Okay. So let's also take that out. Jeez Louise. Alright, let's go all the way up. And we're gonna define this. Right. Wait, equals this minus 3. Last triplet equals this minus 3. I hope that works, you know. We're gonna see. Wait, didn't we already have a max function string size? And it already includes a goddamn, you know. Wait, what did I want? So I wanted a Turing triplet string size? Nah, bro, I could use this one. Transition max function string size. Transition function string. Yeah. Yeah. Okay. So this is a Turing string. We have the max. and a few more errors, just a few more errors. Let's go to 187. God damn it, what did I do? I don't know what I'm doing, because I'm trying to make this, I'm trying to jump to a location. Wait a minute, if I do C, does it print out like, nah, I don't know, never mind. Let's do that. Okay. So this is 187, which is right here. Okay, doesn't like the parentheses. Apparently. Initializer, bro. What the? Oh, this is something that got renamed, I think. Is it? Why is it thinking this is supposed to be initialized? Uh-oh. Something's happening here. Something is happening here. Guys, this is, this ain't it. This is not it. So, I can't type this? 3 times 2 times this minus 1? Bro, what the heck? I'm not sure. Okay, hold the phone, bro. So this is giving us problems. Where is this? Where is this? This? It's right here. This is where it's initialized. So why then? Also, in Nano, how do we view the lines? Can I do that? Huh. Do I see the line? Oh, I do this to see the line. That's only the current line though. I don't want the current line. I want to always see it. So I gotta put this in a file in here. Let's do that. Let's get out of this actually. So let's do this. Go in here. Put this in here. Okay, and now Nano. There we go, right? Yeah, now it has the line thing on the bottom. That's nice. Alright, let's do another compile. go down a little bit, and okay. We got problems. We got problems here. What is this? So 3. This is so weird. What is it doing with this? What is it doing? What do you think you're doing? Okay. I really don't understand why this is broken. So I'm gonna do this, and this is the only place we use that. So here we have on line 211, and then 231. And then it just goes back to this. So apparently something is happening here. Oh, it's because this isn't a constant. Oh. Come on, bro. Can it just work the first time? Do I really gotta figure this out, bro? So this has to be a constant, which is the problem. So this, like, what do I gotta do? Do I initialize it as something? I gotta have some sort of like initial, I don't know, bro, some initial thing. I don't know, cause what is up with this? What is up with this? So I use it here, which is another problemo. So the last triple I, okay, I see what's happening. I see what I must do now. Okay, so one thing I gotta do is make sure this works properly. So I'm gonna be testing that. But I'm gonna try it with number of states equals 2 or something. But what I do have to do is move this somewhere else, because this cannot be here apparently. It has to be a constant. Or I put it inside of a function, which I will be doing. What's up with this? Oh, this code is different because I wrote it on the browser thing. Yeah, damn it. All right, let's do that. Okay. So last triple. I don't know. I don't know what to do with this. So this is what it initializes as. But when this gets called, Yeah, bro, I should have been... I think this code is too big now. Or like I jacked it up. I think I should be making like a struct, perhaps, with initial values, maybe, to handle all this, instead of making a bunch of variables in here willy-nilly. Yeah, that would be better probably. Okay. I don't know. I'm just gonna keep writing this code though. See what happens. I'm only one man army. All right, let's see. So we got this thing. Initializes to this. God damn, bro. I'm kind of hungry. I'm kind of thirsty. I'm hungry. I'm thirsty. Yeah, bro. That's what's up. That is what's up. But yeah. So here we go. I gotta see where this gets used, which is here. Okay. Maybe I could make a function, right, that says reset Turing triplet stuff. That's interesting. So we got that, and then we got this. All right, so this could equal 0 to begin with, but this we don't know what it equals, so we could we gotta call this if we want to use this stuff. So the next Turing triple. So before we use the Turing triple code, before we call this, we gotta call this. So yeah. So I'm gonna put this here. Oh, my terminal is lagging. I think it's my internet. God dang it. Yeah, let's almost got it. Almost got it. We're going to line 187. Oh yeah, it's this. Okay. Yeah, okay. Let's gonna do reset Turing triple. I guess. We're gonna make this. Wait, so 0. What is this? This is more like we're initializing it. Actually. I have another idea. Okay. I have another idea. Let's, we are going to, we're gonna, okay, I have an idea. So, when we change the state, okay, when we change the state, we're gonna add a function. for when we change the state. And that probably, I don't know where we're gonna put that, but alright, so this is gonna be there, right? So yeah, so we're gonna do this, change state number, and it's gonna change everything that depends on the state. So god damn it, that's what we're gonna do. So it's gonna change this. Alright, it's gonna change this. This is a really weird thing. I've never done this type of code. That did not copy. Okay. So this goes here. So change state number. Yeah. And then here I'll say we're gonna do change state number to 5. Okay, so that will, yeah, that'll define that. I'll do this, it'll do this, alright, and that means we don't need this here, which is good. Okay, we don't have to call it here either, which I'm just gonna comment out, and let's do this. So whoops, what is this? Alright, let's go to 187, and this will be calculated. Whoops. That will be calculated. Alright. Make sure we got that. Yeah. Yeah, so right here. That's what we gotta do. And this. Well, that was interesting. So here we did init new. I should probably change this, right? Let's paste dot there, make it cleaner, and the print Turing chart, we just we want to make it go print all of them, which it did not, so that's cool, very cool. So we've officially broke the code. Awesome. Not really. So bro, what? Why you do this? Why you do this code? Oh my god. So somewhere it's just not working. I broke it and I don't know why. This is what GitHub is for. I mean I'm supposed to make commits, and when it stops working, you know, I can follow the changes, see where it broke, see where it stopped compiling, but nah bro, I did not do that. But yeah, whatever. So yeah, let's see. So we got last triple I, next triple, current triple, the string. Okay, this is cursed, bro. This is cursed. Like, what is this? Where is the string? It's up here, I think. Oh, no, it's not up here. God damn it. Get out. Alright, let's go here. Let's do change states. Let's change that to 5. Oh, I have a question. I have a question. Wait. Number of states. Wait, number of states? Number of states? This is +1. Maybe that's why it's not working. Nope. Oh god, what it the... Oh my god. What the heck? Number of states. Last triple. Is this equal to 0? Oh my bad, yeah, it equals 0. Of course it doesn't work, bro. Of course it doesn't work. There we go. There we motherfucking go. There we go. Okay, so the problem with this is it's broken. Busy Beaver 5 has been broken. I suspect we are not... When I change this to 2, it doesn't work, I think. So let's test that hypothesis. Oop, it's just broken. Alright. It's broken. Okay. So something is breaking somewhere. It could be... I don't know. I do not know. Could it be this? Could it be this? Could it be this? Could it be this? Run into a hall or Busy Beaver. What is it? T-step? Is it the... Did I not update something properly? Is it the state? Is it the tape? The transitions? You know? Oh. Uh-oh. Oh, still doesn't work. Okay. Okay, I see you. So max states is still gonna be 6 for now. And this is still 6 for some reason? What is this? Max states? What the heck, bro? Why is my code so inconsistent? Why is it so inconsistent? All the wording is not like... My own code is confusing me. Like, bro. Max states, that should be 6, right? You would think that would be 6. So I'm putting that to be 6. Number of states is 6. Yeah, max states. Let's... Oh my god. So... Let's just read this. Transitions, max states. Oh, interesting. Interesting. There's errors now. There are errors. Yes, indeed. Right there, we got an error. Right here. This could be -1, but doesn't... I don't know if it matters exactly, but whatever. whatever. Okay, so we got some stuff here. Alright. Got some stuff here. Okay, we got code. Here we got stuff there. This equals 0. But we do change that. Okay. So yeah, oh my god. So I fixed the compile errors and warnings, but now it just like doesn't work. Doesn't work properly. Oh my god. So what is this? Run until halt or BB? Is that correct? Is that correcto? Is that correcto? Oh my god. Alright. Here's what I'm gonna do. Here's what I'm gonna do. Outro. Okay. We are going to do int result halt equals t step. Okay. If halt equals t true, then return counter. But not only that, we're gonna do a print. I'm gonna say halted. Wait a minute. I feel a brain blast. I feel a brain blast. Think about it, guys. Where has this functionality been coded before? Where has it been coded before? Boom. Debug, baby. Debug. Alright. Let's see. So if it halts, I will say we're gonna print out something here. We're gonna say halted. Halted. It did not reach halted. It just stopped. So that's how you know it didn't halt. It did something else. Okay, that's so funny. I'm gonna start laughing. How funny that is. So maybe something that happened was this number, you know, compared to this number turned out to be true. Maybe comparing a uint 64 and an int is not that easy. So let's try it out in the online C compiler. Alright, so let's make a uint thingy-majigger. Let's copy. Alright, let's call that right there. Okay, and then B is gonna be this. Wait, hold up. Hold the phone. Hold the actual phone. No, we're gonna use that. I thought something was different. We're going to print A smaller than B. We're going to print A equals B. We're going to print A greater than B. I don't know. I don't know which one is which. B for Boolean? Oh my god. How does it work? So 0 is false, anything else is true. So yeah, obviously it's smaller. Yeah, no, it's obviously smaller. So why is it stopping? Why is it stopping? Is it this? Printing? Is the printing a little weird? I don't know. Is it weird? So if it does not halt and it is under the Busy Beaver steps, let's say it is not equal. God damn it, what did I do? Let's say it does not equal. How about that? It's still... What is up with this number, by the way? Is this a specific... Is this a special number? Or something? Let me do log base 2 of that number. Oh! Wouldn't you know it? It's to the power of 14. Isn't that really, really, really close to our tape size? Which was like 2 to the power of 15? So why is it stopping on 2 to the power of 14? Tape pi. I mean, it's not halting, right? It's not halting. It's oh, it is halting, right? It's right here. Okay, let's okay, let's print halted. Okay, it still doesn't say it halts. So it must be reaching like the Busy Beaver value. Why, bro? Why, bro? Why? Okay. Run until halt, okay. Let's run until halt. Let's do a variant of this function, which is the same thing except it doesn't do the Busy Beaver thing. So look at that. That's gotta be super easy. Right? Super duper easy. Yeah, and let's do that. Okay, so this continues for a long time. Let's also, we could probably move this maybe like here, you know, just make it easier to find it. Yeah. So let's take out debug, and would you look at that? Would you look at that? It was the Busy Beaver thing. So how did I not code this properly? Because, hello? Oh, number of states. Well, yeah. Whoops. Oh my god. I knew it was easy. I knew it was a simple... Yeah, there we go. I knew it was easy. I knew it was a simple, easy thing. Alright, that works. So let's try to get this to work now. Cause it... Oh, it is. It is working. Okay, print, and let's put LD, let's call it UN64, and let's put Mr. Count. Let's put the Count Dracula. Look at that, beautiful guys, beautiful. It's so quick. All right. Let's calculate this, see if that's the right amount, right? What was it? 24 to the amount of states, or how many? You know, one. Well, I think it's what is this? So I got 2 states. How many transitions are here? So I got 1, 2, 1, 2. So I got 4 transitions. The number I got was a lot bigger. It's like 331,000. So this might be incorrect, but it just looks right. It just looks right. Because if you... This is 0, 0, 1, you know, then it goes here, and then... Oh, hold the phone, guys. It's not 24 now. It's not 24. Because it's n+1 here, it's not just 24. Because if we had 2 states... Oh, come on, guys. We got this, bro. We got this. Alright, I'm gonna type it in the calculator. So I got 4 times n+1 to the 2x power, right? And when I plug in 2, I get the correct amount. Okay, so 2 is 20,736. And the reason it's 1 off is because we gotta start at 1. There we go. Okay. So things are working. Everything is working now. Because look at this. I'm gonna do this. Alright. And I'm gonna run the Busy Beaver and hopefully, look at that. Busy Beaver works too. That's good. Oh my god. Alright, I'm gonna call it. I didn't get to work on the algorithm that I am aiming to implement, but that's alright. When the time comes, you know, I needed this to work before I can do that algorithm anyways. So yeah, and I needed it to work with like the variable states or whatever. That's what I was kind of doing. So yeah, that took as long as it took. Alright, so if you guys have any suggestions, you know, put them in the comments. You know, I read the comments. So yeah, if you have any music suggestions, maybe change the background. Do you like the background? Yeah, I added it. I don't know. I think it's neat. Maybe it could be more apparent. If you guys want the background to be more visible or not, you know, maybe you want to see more coding or Erasio or whatever. I don't know. Yeah, bro. I love you guys. Peace out.